Good evening, Devang, and good evening, Abhisha. Can you hear me?
Good evening, sir.
Good
Good
evening,
evening.
sir.
Okay. So first of all, I'm going to discuss the homework questions. Okay. Yesterday I'd given some homework questions. Okay. I see that everyone has solved it, right? Abhisha, Devang. Abhisha, you have sent me. Abhisha and Raktim has sent me. And Devang, did you
Sir, I
solve?
have sent you. Yes, sir, I sent you.
Oh, you have also sent me. Achha. Shamita and
Yes.
okay. Oh, Nini, did you solve?
No, so I only saw it in the evening and then I had another class. So,
Achha. Okay. Anyways, you solve it later. I'm just
yes, sir.
writing down the answers. Okay. Okay, everyone, I'm writing down the answers. I'd given some homework questions. If you people find any doubt, let me know. Okay. So these were the homework questions. Tell me. These were the questions I had given. Tell me, everyone.
Yes, sir.
Okay. Okay, let us discuss. Just give me 1 minute. Yes. Let me see. Okay, what was the last one over here? Okay, this is the last one. What is the last one over here? Okay. So x square. Okay. Good evening, Debatri. Can you hear me?
Yes, sir.
Okay. Debatri, are you fine now? You'll be able
Yes,
to
sir.
do the class? Okay.
Yes.
So, did you try to solve? Did you solve these problems? Tell me.
Sir, actually, I just covered classes part with the homework. I wasn't able to complete.
Okay. After the class, you try them out. Okay.
Yes, sir.
Okay, everyone. I'm going to write down the answers. Over here, the domain is. Everyone, pay attention. Over here, the domain is open 1 to 2 closed. Okay, and range is open 0 to no close 0 to infinity open. Okay. Anyone having any doubt, you can ask me. Over here, the domain is r minus 0. Everyone knows. It's very simple. R minus elemental 0. And over here, the range will be equal to from 0 to infinity. If you people have any doubt, you can ask me. Next, part 3, the domain will be equal to, domain of the function will be equal to n pi from n belongs, I mean, for n belongs to integers. Okay. And range of the function will be elemental 0. Okay. Next, signum of cos of sin x, domain is all real. Okay. Tell me, anyone having any doubt, you can ask me. Aviksha, Raktim, Shamita, Devang, tell me. Okay, you people want me to draw the graph of any of the functions? Tell me. Y equal to e to the power x plus 1 minus 10. Y equal to ln of x minus 2. Signum of x cube minus x. I'm drawing the graph of signum of x cube minus x. Pay attention. Okay. Wait a minute. I'm drawing the graph. Okay. Signum of x cube minus x. This is how the graph is going to look like. So first of all, you see, you need to draw the graph of x cube minus x. Okay. The graph of x cube minus x, roots will be 0, 1, and minus 1. It will look somewhat like this. Okay. Means from 0 to 1, from 0 to 1, the graph is positive. Sorry. From minus 1 to 0, the graph is positive, and from 0 to 1, it is negative. Okay. So signum of x cube minus x will look somewhat like this. Okay. Up to minus 1, it will look somewhat like this. Then after minus 1, Uh, I mean, up to -1, it will be open. I mean, this will not be included. Then -1, it will be somewhat like this. Then after -1 to 0, it is somewhat like this. Y equal to 1. Okay, then at exactly x equal to 0, you will get a shaded circle. Okay, you people got this graph only, right? Raktim, Abhipsha, Devang, Shomita. Tell me, did you people get this
Yes, sir.
graph?
Yes,
Yes.
sir.
Yes.
Okay. Next, if you have any doubt in any of the other graphs, let me know. I'll draw it. ln x minus 2. Okay. Find the range of signum of x. Okay, over here, the range will be -1, 0, 1, elemental -1, 0, and 1. Okay. Next, over here, only elemental 1. Anyone having any doubt, you can ask me. Over here, it will be 2. Tell me, Raktim, Shomita, Devang. Anyone having any doubt, let me know. Okay. Next,
Sir,
moving on to question.
sir,
Tell me, Raktim.
in question number 4.
Tell me. You have a
Sir,
doubt?
yes, sir. If X belongs in first quadrant, then sir 4 is coming.
X belongs in first quadrant, then 4 is coming. Hmm? It is not n pi by 2, na? Try to understand. It's not n pi by 2. So signum of sin x will be equal to 0. Signum of cos x will also be equal to 0. Are you getting?
Oh, yes, sir.
Tell me. Signum of
Yes,
sin x will be equal to 0. Signum of cos x will also be equal to 0. Okay. Signum of tan x can give us 0 or 1. Signum of cot x can also give us 0 or 1. Okay. But when this gives us 0, this will give us 1. When this gives us 1, this will give us 0. So in the first quadrant, it will be only 1. Are you getting?
yes, sir. Now understood.
Okay. Anyone having any doubt, you can ask me now. Tell me. Okay, moving on to question number 5. Just let me see. Okay. Number 5, it will be closed 5 to open infinity. Closed open 5 to infinity. Union elemental 4. If you people have any doubt, let me know. I'll explain. Next. 0 to 2, union 3 to infinity. 0 to 2, union 3 to infinity. Okay. Next. Next one will be over here null set. Anyone having any doubt, you can ask me. Over here x belongs to minus infinity comma 0. Tell me. Anyone having any doubt, you can ask me. Number 5. Number 5 will be 2 and pi plus pi by 6. Tell me. Devang, Raktim, Shomita.
Sir, can you please solve number 5?
Number 5. Okay. So if you see over here, you have root over sine of cos x plus ln of this plus root over log of this. Okay. So Shomita, I'm going to focus in the last term. Okay. I'm going to focus in the last term. Okay. So in the last term, Abhisha, you see part 5. In the last term, you see you have got log of base 4 over here in the numerator 4 by 3 plus 2 sine x plus 1 upon 2 root 2 sine x. Right, tell me, Abhisha. Abhisha,
Yes, sir.
over here you notice, okay, that this is under the root. Okay, this is under the root. This will only be defined. This particular expression will only be defined if this log is greater than 0. And when will it be greater than 0? When this 4 by 3 plus, okay, this 4 by 3 plus 2 sine plus 1 upon 2 root 2 sine must be greater than 4. Otherwise, it's not possible only. Tell me, are you getting Ayusha?
Yes, sir.
If it is less than 4, oh, wait a minute, wait. I'm making a mistake. It should be less, it should be greater than 1. Sorry. Okay. Means both the number. and the base should be on the same side of unity, right? Should be greater than 1. Then only it is positive. Otherwise, it's not positive, right? Okay, so it should be greater than or equal to 0. Tell me. Greater than or equal to 1. Tell me. Is it clear, Aisha? This implies 3 plus 2 sine plus 1 upon 2 root 2 sine must be less than or equal to 4. Tell me. Is it clear, Aisha? Is it clear to others? Tell me, Ondini, Tabatri,
Yes, sir.
and
Yes, sir.
Rakti. Are people getting? Okay.
Yeah.
Yes, sir.
So from here, 2 sine plus 1 upon 2 root 2 sine, okay, must be less than or equal to 1. Okay, this implies 2 sine plus 1 must be less than or equal to 2 root 2 sine. Okay, taking this to the left hand side, you will be able to see that you are getting a perfect square over here. Tell me. Right, are you able to realize? Are you able to visualize this? Tell me. We are
Yes, sir.
Yes,
getting
sir.
root over 2 sine x minus 1 must be uh, whole square must be less than or equal to 0. This will only be possible if root 2 sine x must be equal to 1. Otherwise, it's not possible only. Okay, this implies sine x is equal to half. If sine x is equal to half, x is equal to 2n pi plus pi by 6. This is the only thing that is possible. After this, you have to check whether for x equal to 2n pi plus pi by 6, the other terms are positive, other terms are defined or not. This will be defined. This is okay, right? Because sine of cos x, it will be in the first quadrant, so it will be defined. Next, when you substitute 2n pi plus pi by 6, over here, what is cos square 6? Cos square x, tell me. What is cos pi by 6? Cos pi by 6 will be equal to root 3 by 2. So it will be minus 2 into 3 by 4 plus 3 into root 3 by 2 plus 1. So, Aisha, is this greater than 0? What do you think? This is greater than 0? Yes, so everything is defined. So hence the domain is 2n pi plus pi by 6. Tell me, is it clear, Aisha?
Yes, sir.
Okay. Tell me, Devank, Onini, Raktim, Shamita, are people getting yes or no?
Yes, sir.
Yes, sir.
Debatri, is it clear?
Yes.
Yes, sir.
Yes, sir.
Okay. Next, let us move on. Okay, our next one is find the domain and range of this one. Okay, over here, domain is all real. Over here, the domain is all real. Range of the function is elemental 0. Okay, next. Number part 2. Anyone having it out, you can ask me now. Domain of the function over here will be equal to elemental 0, 1, minus 1 by 3, and 8 by 3. Tell me. Anyone having any doubt, ask me. And range of the function will be
Sir,
elemental
can you
0.
please solve this one?
This one. Okay, let us start. Okay. Again, over here also we are going to use the same kind of logic. See, when will this be lock be defined? Tell me. When both the number and the base will be on the right hand side of unity, right? Base is already on the right hand side of unity. Okay. That is 3 is already greater than 1. That means 4 upon 4 plus. But see, Aibsha, you have got 4 upon 4 plus something. And this is greater than or equal to 0, right? Tell me, Aibsha. Pay attention.
Yes, sir.
This is a very smart observation. You see, this is greater than or equal to 0. That means the denominator is greater than or equal to 4. But if it is greater than 4, if the denominator is greater than 4, the whole fraction will become less than 1. Right, Oisha? Which is not possible. Tell me. Are you getting Oisha? The whole fraction cannot be
Yes,
less
sir.
than 1. So the only thing that is possible is box of x square minus x minus 2 into fraction part of x must be equal to 0. Right, tell me. Are you getting Oisha? Otherwise, it's not possible only. Tell me.
Yes,
Are you
sir.
getting Oisha? Okay. Now we need to find out the value of x. Okay, let us start. So from here, what are we getting? Box of x square box of x square minus box of x minus fractional part of x. Okay, I've changed x as box of x plus fractional part of x. Okay, minus 2 into fractional part of x will be equal to 0. Okay, so from here, what are we getting? Box of x square minus box of x must be equal to 3 into fractional part of x. Right. So, Aibshad, tell me, what is the range of fractional part of x? What do you think? What is the range of the right hand
So
side?
close 0 to 1 open.
Range of the fractional part, range of the right hand side, range of RHS will be equal to 3 into close 0 to open 1, right?
Yes, sir.
Okay, that means 3 0 comma 3 open, closed open. So now see, the left hand side is an integer, right hand side should also be an integer, right? Acha, tell me, what are the integral values we can take? 0, 1 or 2, right? These are the only three integral values that can happen, isn't it? Tell me, Aibshad.
Yes, sir. Yes, sir.
So we can start up with box of x is equal to 1. Box of x equal to 1 will work, right? Box of x equal to 2, 2 square minus 2 will also work, right? Box of x equal to 3, 3 square minus 3 will not work. Are you getting? It will lie outside the range. Next, box of x equal to minus 1 will work. Minus 1 means this will be 1, 1 minus of minus 1. So 2. Yes, box of x equal to minus 1 will work. Minus 2 is 4. 4 minus of minus 1, 5. No. So these are the only three things that are possible, right? Box of x equal to 0 will also work. Right, tell me. Up until this much, it is clear or not? Tell me.
Yes, sir.
So if box of x is equal to 0, what is the fractional part of x? Tell me. This implies what is fractional part of x? Tell me.
0.
0. This implies x is equal to 0. Right. So 0 is one of the possible answer, one of the possible value in the domain. Next, if box of x is equal to 1, what is fractional part of x? Tell me. Tell me, what is fractional part of x? See this equation. Find out fractional part of x from this equation. Tell me, Vaibsha, what will be the value of fractional part of x?
0.
0 only. So this implies x equal to 1 plus 0, 1. Next, let us talk about box of x is equal to 2. In this case, what is the fractional part of x? Tell me.
By 3.
Okay. So this will be equal to 2 square minus 2, 2. How much? 2 by 3, right? How much you said?
Sir, I said 2 by 3 only.
Yes. This implies x equal to 2 plus 2 by 3, that is 8 by 3. Tell me. Next. Lastly, if box of x is equal to minus 1, then in this case, what is the fractional part of x? Fractional part of x will be equal to, check and tell me.
So 0.
0. Think. It will be minus 1 whole square minus of minus 1, right? How much are we getting? 2 by 3, isn't it?
Yes, sir. Yes.
This implies x equal to minus 1 plus 2 by 3. That will give us minus 1 by 3. Therefore, the domain of the function will be 0, 1, 8 by 3, and minus 1 by 3. Okay. So I've got the domain. I can find out the range also. Now see, whatever value you substitute over here, okay, this should always be equal to 0, right? And log of 4 by 4 plus 0 will give us log 1 to the base 3, log 1 to the base 3 is 0, right, Oisha? Therefore, the range of the function will always be elemental 0. Tell me. Is it clear, Abhipsha?
Yes, sir.
Okay. Tell me, others. What about others? Others have understood? See, it's not that tough. You just have to solve step by step, you'll get it. Okay. Shamita, Raktim,
Yes.
Onlini,
Yes, sir.
and Devatri, is it clear?
Yes, sir.
Okay, let us move on. Okay. Next. Next problem was this one. Okay, this one, Hermite's identity, 75 is the answer. Next. Anyone wants me to draw the graph of y equal to box of x square? Tell me. Anyone? Okay. Next. Over here, last one. This came in JEE Mains. X belongs to minus infinity comma minus 2. Anyone having any doubt? Tell me. Union, close 6 to infinity. Tell me. Devank, Raktim, or Nini, Shamita, Abhipsha, Devatri, tell me if you have any doubt
No,
in number
sir.
9. Okay. Then we can continue with today's topics. What was the last thing done? Let's see. And those who haven't solved it yet, I mean, completely complete it as soon as possible. Okay. So last day we had done many one functions. Okay. So we'll continue, everyone. We'll move on with many one functions. Okay. Identical functions we have done yesterday. Okay. So last day we were doing many one functions. Okay. One, many one was done. Okay. Okay. So everyone, our next topic is onto functions. Pay attention, everyone. What are onto functions? Onto functions. Okay. Onto functions means surjective functions. Surjective functions. Okay. So what are surjective functions? Surjective functions means codomain is equal to range. Means whatever codomain is given, if the whole codomain set is exhausted by the range, then they are known as onto functions. So if the function f maps A to B, if the function f maps A to B is such that is such that each element in B is such that each element in B, that is a codomain set, each element in B, that is the codomain set, is the F image, is the F image of at least one element in A, of at least one element in A. Okay. If the function f maps A to B is such that each element in B codomain set is the F image of at least one element in A. Okay. Then we can say, then we say that F is a function of A onto B. Okay, F is a function of A onto B. Note if codomain is not equal to range. Okay, if codomain is not equal to range, then the function is into. Then the function is into. Okay. So everyone, let us do some problems. Question number 1. You people tell me whether the following functions are into or onto. Part 1. F maps R to R. f of x is equal to 2x plus 1 is onto or into? Is onto or into? Everyone write it in WhatsApp quickly. You have to tell me whether this function is onto or into. Tell me. Okay, or Nini, check your answer again. You are making some mistake. Yes, Soipsha, right answer? Yes, Devatri, Raktim, your answers are correct. Yes, Shomita, right answer. What about others? I think, yes, Devank, your answer is correct. Okay. So, Andini, over here, what is the range? Tell me. Raktim,
Sir,
your
I've
answer is
understood.
correct.
I sent it.
Oh, yes, 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 yes. Okay, okay. Okay, I didn't see your second answer. So, of
Okay,
course,
sir.
everyone, it is on to. Okay. As you can see, that the range of the function is all real. Okay, next. Next one, tell me. Part 2. F maps R to R plus f of x is equal to e to the power x. Tell me. Onto or into? Tell me. Everyone should write down the answers. Raktim, your answer is correct. Devatri, check your answer again. Shwamita, right answer. Abhisha, right answer. Onini, right answer. Devatri, your answer is correct now. Okay. So this one is also onto, right? Very easy. Because you can see that the range of the function is open 0 to infinity. Okay. That is R plus. Therefore, F is onto. Next. Another one, everyone. Part 3. Part 3. F maps R plus 2R. F of x is equal to ln x. Tell me. Onto or into? Yes, only right answer. Raktim, right answer. Shwamita, right answer. Abhisha and Devatri, your answers are correct. So only Devank is left. Devank, should I solve? Tell me.
Sir, is it into?
It will also be on to, right? What is the domain of the function? Tell me. Domain of the function is all real.
All, all real, yes.
So therefore it is on to. right?
Yes, sir.
Okay, next. Diagram of onto mapping. Everyone pay attention. I'm going to draw the diagram of onto mapping. Okay, how will the diagram look like? Okay, okay. So let us say a mapping is defined from A to B. Okay, a mapping is defined from A to B. Tell me, is this onto? What do you think, everyone? Is this onto?
Yes, sir.
This is onto. Okay, next. I'm going to show another example. You have to tell me whether it is onto or not. Okay, tell me. Is this onto? Wait. Is this onto? What do you think?
Yes, sir.
Okay, another diagram. Okay, is this onto? Tell me.
No, sir.
No, over here, this is not onto. Okay, everyone. Next, into function. So you people must have understood the definition of into functions. Okay, into functions means range will be a subset of codomain. Range will be a subset of codomain. Okay, so if F maps A to B, if F maps A to B is such that, if F maps A to B is such that there exists, there exists at least one element in codomain, at least one element in codomain, which is not the image of, which is not the image of any element, of any element in domain. Okay, means one of the element in the codomain set is left out. At least one of the element in code in the codomain set is left out. Okay, then f of x is into. Then f of x is into. Okay, like see the last one was into mapping. This one is into mapping. Okay, next I'll show another one. This is also an into mapping. Okay, this is also an into mapping. Okay, next. For example, f maps R to R. F of x is equal to fractional part of x. Okay. So over here, what is the range, everyone? Tell me. What is the range of the function? Range of the function is? Tell me, what is the range of fraction?
Close 0 to 1 open.
Close 0 to 1 open. Okay. Close 0 to 1 open. Okay. Which is a subset of R, a proper subset of R. Hence, now over here you see, since range is a subset of R, since range of the function is a subset of R, proper subset of R, so F is into. F is into. Okay, everyone. Okay. Hello, good evening, Ritam. Can you hear me?
Good evening, sir. I can.
Yes, Ritam, you joined so late. What happened?
Sir, I got the link right now.
Right now,
Yes, sir.
let me see. Your mobile data was off.
Yes, sir.
But you knew that the class was today, right? There was a class today
Yes, sir, I knew.
at 9 o'clock. So you should have been ready.
I forgot it was from 9.
Okay, go through the notes. Whatever you missed, go through it properly.
Okay, sir.
Okay, next. Similarly, everyone, similarly, f maps R to R. F of x is equal to box of x, comma, signum function of x, comma, ax square plus bx plus c are into functions. Okay, all these are into functions. Okay, next. So everyone, question number 2. You have to classify the following as into or onto. Classify as into or onto. So Ritam, do you know what are into or onto functions? Tell me.
No, sir.
No. Okay, I'm going to explain a little bit. Pay attention. See, if the function f maps A to B is such that there exists at least one element in B. Okay, there exists at least one element in B. Sorry. Uh, if f maps A to B such that each element in B is the f image of at least one element in A, means the whole of codomain set is exhausted. Codomain will be equal to range. Are you getting? Then we can say it is onto. But if codomain is not equal to range, then we say that it is into. For example, f maps R to R. So Ritam, over here, what is the codomain set? In f maps R to R? Ritam, tell me. What is the codomain set?
2x plus 1.
That is the set. 2x plus 1.
No, sir.
I'm asking you, what is the codomain set over here? F maps R to R, f of x is equal to 2x plus 1. What is the codomain set? Tell me. Ritam, are you able to hear me?
Yes, sir.
Tell me, what is the codomain set? You know the meaning of codomain set, right? Or not?
Yes, sir.
So tell me, what is the codomain set over here in this case?
Sir, I don't know.
You don't know. Whenever f maps A to B, A is known as the domain, right?
Yes, sir.
And B is known as the codomain. The whole of chapter is, I mean, we are in the middle of the chapter. You don't know this. Tell me. Remember, the first one is the domain set, and the second one is the codomain set. Are you getting? So over here, R is the domain, and this R is the codomain set. Now is it clear?
Sir, which R is the codomain?
This R.
Okay, sir.
Acha, what does R means over here? You know,
Which one, sir?
what does R means over here?
Which R?
Any R. Tell me. Any R. What does R means over here? Tell me. Any R.
Range.
Real numbers. Set of real numbers. What happened, Ritam? You're not feeling well.
Sir, I'm having dinner.
You're having dinner. Okay. So anyways, this is a set of real numbers, and the range of the function 2x plus 1 is also a real number set. Now, since the set of real numbers, I mean, the range set is also a real number, therefore f of x is onto. Okay, I hope it is clear to you, Ritam.
Yes, sir.
Okay. Next, everyone, let us continue. Okay, classify as into or onto. Number one. Acha, all our F maps R to R. F maps R to R. Number one. F of x is equal to x minus 1 into x minus 2 into x minus 3. Okay, next, number two. F of x is equal to sine x. Next, number three. F of x is equal to e to the power x. Okay, keep writing your answers, everyone. Number four. F of x is equal to x square into signum function of x. Keep writing your answers. Next, number three. Question number three. F maps R to, sorry, F maps R minus plus minus 1 elemental to A. F of x is equal to x square upon 1 minus x square is onto. Find the interval A. Find the interval A. You have to tell me what is the range of A. Quickly solve, everyone. Quickly solve so that we can move on. Yes, Raktim, 1 and 2 are correct. Part 1 and 2 are correct. Part 3 is also correct, Raktim. Yes, Devank, all your answers are correct. Abhisha, all your answers are correct. Ondini, all your answers are correct. Debatri, first part is correct. Shomita, all your answers are. Shomita, there's this. Shomita, check part 3, 2 part 3. Others
Okay,
are
sir.
correct. Okay, Ritam, are you going to write down the answer?
Sir, I'll do from next question.
Okay. Okay, so pay attention, everyone. Part 1. Part 1, you can understand, everyone, the range is all real numbers. Okay. Debatri, check part 2. Part 3 is correct. Part 1. You can understand that the range of the function is all real. Okay. Which is codomain only. Okay. Hence, f is onto. Okay, next, number 2. Number 2, what is the range? Range is from minus 1 to 1. Right, Debatri, are you getting? Range over here is minus 1 to 1, which is a subset of
Yes,
all
sir.
real. Hence, it is into. Hence, f is into. Next, number 3. Ritam, are you able to understand?
Yes, sir.
Range of e to the power x is open 0 to infinity. Okay, which is a subset of R. Hence, f is into. And lastly, part 4, range of the function is All real. Okay, because it is x square into signum function of x. Okay. So see how it is going to be defined. F of x will be equal to x square when x is greater than 0. It will be equal to 0 when x is less than 0. It will be equal to minus x square when x is, sorry, it will be equal to 0 and over here less than 0. So hence a range of the function is all real. Okay, which is equal to codomain set. Right, tell me. If there's anyone having any doubt, you can ask me. Therefore, f is onto. Okay, tell me part 4 quickly. X square into signum function of x. Tell me. Okay, Raktim, check your answer again. Everyone pay attention. Okay, F maps are except elemental minus 1 to 1, minus 1 and 1. Okay, Devang, Devang, your answer is correct. We need to find out that F is onto. Okay, we need to find out the interval A. Basically, we need to find out the range of this function only. Okay, so there are two methods to solve. Method 1, pay attention. We need to find out the range. Okay, so
Sir,
y
could you
equal to,
please once show the question again?
yes. Okay, are you people able to
Okay.
visualize that over here we are going to, we are actually supposed to find out the range. If range is equal to a, that means the function is onto. Okay, so we are supposed to find out the range of the function only. So f of x is equal to x square upon 1 minus x square. Okay, so
Sir,
what
I
we
have
can do is,
sent you the answer. Can you please check it?
okay, yes, so Avisha, your answer is correct. We can write it as x square minus 1 upon, I'm going to add and subtract 1. Okay, this will give us 1 upon 1 minus x square minus 1. I hope this is clear to everyone. Okay, next, after this, you substitute the range of x square. Okay, now you people can understand that x square belongs to 0 to infinity. Okay, so you substitute x square belongs to 0 to infinity. So this will give us how much? 1 upon 1 minus close 0 to infinity open. Okay, 1 upon 1 minus close 0 to infinity open. Okay. Acha, what is 1 minus close minus 1? Okay. What is 1 minus 1 by 1 minus 0 is minus 1. So closed minus 1 and 1 minus infinity is minus infinity. So it will be minus infinity to minus 1. Minus infinity will be open to minus 1 closed. Minus 1. Okay. Next. 1 upon minus infinity is 0. Okay, so it will be open 0 and 1 upon minus 1 will be equal to minus 1. I think I'm
Sir,
making
x square cannot be 1.
x square cannot be equal to 1. You are absolutely correct. Wait. Over here I'm making a mistake. Okay. X square, it is given that in the domain set we cannot substitute 1. I mean, we cannot substitute 1 or minus 1 instead of x square. So over here it will be closed 0 to 1 open union 1 to infinity. Are people getting? Tell me. Debatri, can you understand why I substituted close 0 to 1 open, union 1 to infinity? Tell me.
Yes,
Hello,
sir.
Debat. Okay. Next. What is 1 minus 0? 1 minus 0 will be equal to minus 1. So it will be minus 1 to 0. Wait. 1 minus infinity is minus infinity. So it will be minus infinity, comma 1 minus 1 is 0. Union 1 minus 1 is 0. Union 0 to 1 minus 1 is 1 minus 0 is 1. 1 closed. Okay. Next, 1 upon minus infinity is 0. 1 upon 0 minus is minus infinity. So it will be minus infinity comma 0 union 1 upon 0 plus is infinity. 1 upon 0 plus is infinity and 1 upon 1 is 1. So it will be closed 1 to infinity open minus 1. Now let us subtract. This will be equal to minus infinity comma minus 1 union close 0 to infinity. I hope it is clear to everyone. Tell me. On any, is it clear? And
Yes, I just solved it.
yes. And Devatri, have you understood this part?
Yes.
Okay. And even if you if you cannot substitute the range and find out the final range, okay, what more you can do is, you people remember quadratic by quadratic. I had taught you how to find out the range of quadratic by quadratic. So what you do is, you write down y equal to x square upon 1 minus x square, cross multiply, you are going to get 1 minus x square is equal to, multiplied by y is equal to x square. So from here, what is the value of x square, everyone? X square common, we are going to get 1 plus y is equal to 1. Okay, everyone. So from here, sorry, is equal to y. So everyone, x square is equal to y upon 1 plus y. Now, since x square is greater than or equal to 0, everyone, this implies y upon 1 plus y is greater than or equal to 0. Okay, everyone. So see, what are the critical points? Critical points are minus 1 and 0. Okay, this is how the parabola is going to look like. Okay, wavy curve is actually going to look somewhat like this. So this implies x belongs to minus infinity comma minus 1 open union close 0 to infinity. Why it is open? Because minus 1 is a discontinuous point. Tell me. If there's anyone having any doubt, you can ask me. Next. Note, note number 1. Range of an even degree function. Range of even degree polynomials. Range of even degree polynomials. Range of even degree polynomials is a subset of R. Okay. This is very simple. You see range of quadratic. Okay. Range of quadratic can never be the whole of R, because if the graph is going down, it will definitely come up. Okay. It cannot go down and down and down. So range of even degree polynomials is always a subset of R. Whereas range of odd degree polynomial is always R. Range of all odd degree polynomials. Ritam, are you getting?
Yes, sir.
Is that okay? Next, number 3. Now see, either a function is into or the function is onto. So can I say that the total number of mappings will be equal to the number of into functions plus the number of onto functions. The number of into functions. Okay. Next, number 4. A function can be one of the, I mean, can be a function can be one of these 4 types. Okay. Can be one of these 4 types. Okay. Pay attention. Number 1, 1 onto function. Okay. 1 onto functions are very important. 1 onto functions means both injective and surjective. Both injective and surjective. Okay. How will it look like? Pay attention. Okay, how will it look like? So see, it will be both 1 1 and into as well. Okay. So this is a mapping F from A to B. Okay. This is how it is going to look like. Each and every element of A is mapped to a unique element of B. Okay, and the whole of the codomain set is exhausted. Okay, and over here you see codomain is equal to range. Codomain is equal to range. Next, hence it is called hence it is known as a bijective mapping because it is both injective and surjective. Known as a bijective mapping. Also, everyone, uh, why it is known as a bijective mapping? Because you see, we can also define a function from B to A. Can you people understand? Over here, we can also define a function from B to A because is each and every element of B is attached or it is related to some element of a unique element of A. Okay. So we can define a function from B to A as well. Okay. Hence, it is also known as a bijective mapping. Next, what do you people think? Is this bijective? Pay attention. Is this bijective? Tell me. What do you think?
No, sir.
No, it is not a bijective mapping. Right? Onrini, Ratim, Devang, Shamita, are you getting? Ritam, are you
Yes, sir.
getting?
Yes, sir.
Not a bijective mapping. Because it is not subjective. Okay, one of the element is left out. Okay, next. Our next one is number two. 1 1 into 1 1 into. Okay. Injective but not subjective. Injective but not subjective. Okay. 1 1 into injective but not subjective. Okay. So you can see that the previous diagram we drew, this is injective, but it is not subjective. Okay. Next. Next is many one on two. Means it will be many one, but the whole codomain set is exhausted. Okay. Many one into. Okay. Injective but not subjective. Oh, wait a minute. Many one on two. Okay. Okay. So over here, this is subjective but not injective. Subjective but not injective. Okay, everyone. Subjective but not injective. Okay. So how it will look like? Pay attention, everyone. Means the whole of codomain set will be exhausted. Okay. Whole of codomain set will be exhausted. Okay, but it will not be injective, everyone. Okay, it will be many one like this. Okay, I hope you people can understand. Next, part 4, many one into. Okay, many one into means neither surjective not injective. So a function can be any of these four types, neither surjective nor injective. Okay, so how will it look like? Okay, so see everyone, this is neither injective nor surjective. Tell me, is there anyone having any doubt? You can ask me. Tell me, Avsha, Devang, Shwamita, Devatri, are you people getting? Onlini,
Yes, sir.
Ritam, are you getting?
Yes.
Yes, sir.
Yes, sir.
Okay. Raktim, is it clear?
Yes, sir.
Okay. Okay, just give me 1 minute. Okay, next. Neither subjective nor injective. Okay. Next, everyone. Okay. Next. If F is both injective and surjective, okay, we have to focus on this one. Okay. 1 onto mapping. Okay. If F is both surjective and injective, if F is both surjective and injective, then it is called a bijective mapping. Then it is called a bijective mapping. Okay. The bijective mapping is also called invertible. The bijective mappings, okay, means their inverses exist, right? We have done it in ITF, right? Already, Raktim, Devang, I've taught you when a function is invertible, right? Raktim, you remember, are also called,
Yes, sir.
are also invertible. Okay. For example, you see why they are called invertible. Pay attention. Because you can define a function from B to A also. Okay. Over here, we can define a function from B to A also. Right. Devatri and Oipsha, are people getting? Like, if I want to define another correspondence, another function from B to A, it is possible, right? In this case, yes or no?
Yes, sir.
And Abhipsha, are you getting?
Yes, sir.
Shwamita, Ritam, are you getting? We'll be able to define another correspondence from B to A. Okay, next. This is part A. Part B. Okay, part B. So tell me, everyone, in this case, will we be able to define a function from B to A? Tell me, raise your hand. Will we be able to define a function from B to A? Raise your hand and tell me. You have to also give the reason. Yes, Aisha, tell me.
No, sir, because one element will not be mapped, so it will not be a
Function
like
from B to A.
no image will be there, and yes, sir, it will be not a
Yes.
function.
So it will not be a function, everyone. Here, we cannot define a function. Here, we cannot. We simply cannot define a function. Here, we cannot define a function from B to A, from B to A as one of the element, as one of the element, as one of the element in B has no image in A. Okay, I'll give you another example. Okay, part C. Okay, tell me, will we be able to define a function from B to A in this case or not? Raise your hand and tell me. You have to give me the reason also. Will we be able to define a function from B to A? Yes, only tell me.
No, sir, because one element will have two images.
Exactly, absolutely correct. Over here also, we cannot define. We cannot define a function. We cannot define a function from B to A. From B to A as one element. As one element in B has two images in A. Has two images in A. Okay. Next, part D. Another example. You people have to tell me, will we be able to define a function from B to A? Yes or no? Raise your hand. In this case, raise your hand. For this one, Raktim, tell me.
So this is many on and into, so that will not define.
But will we be able to define a function from B to A? This is many one into that we know. But
Yes,
will
sir.
we be able to define a function from B to A? Is it possible?
No, sir.
No. Why?
Because sir, this is not bijective.
That will come to the conclusion that it is not bijective. But why won't we be able to define a function from B to A? Tell me.
Codomain
What is
is
the
not equal to range. The
because?
codomain is not equal to range.
No,
Codomain is not equal to
because
range.
one particular element, one particular element has two different images. Will have two different images in the other set. Are you getting? Remember, I had told you that diverging is not possible. Converging is possible. Converging is fine. Diverging is not fine. Right? Do you remember? Yes or no?
Yes, sir.
Okay. Hence, only mapping A is bijective. Hence, only mapping A is bijective. Okay. Next. Okay, let us do some problems, everyone. Okay, you people have to tell me what kind of functions are these. Wait, I'm posting the questions. Okay, solve everyone. Solve. Okay, what was the last question we did? Question number. Last was question number 3. Okay, this is question number 4, 5, and 6. Solve quickly. This is question number 4, question number 5, question number 6. Solve quickly. See, in the first one, you need to understand whether it is injective or surjective. Okay. A function can be any of these 4 types, any of the 4 types. Yes, Ritam, first one is correct. Raktim, first one is correct. Devang, you need to also mention whether it is onto or into. Okay, everyone pay
Okay.
attention. Yes, uh, Debatri, first one is correct. Okay, everyone pay attention. Number four. So first of all, you understand whether there exists a minima or maxima or not. Okay. If there exists a minima or maxima, that means the function is many one. Okay. So what is f dash x? F dash x will be equal to 6x square minus 12x minus 18. Taking 6 common, we are going to get, taking 6 common, we are going to get x square minus 2x minus 1. Okay. Is it factorizable? Let me see. Sorry, minus 3. Is it factorizable? Yes, 6 into x square minus 3x plus x minus 3. Okay, which is 6 into x plus 1 into x minus 3. Okay. So yes, there exists a minima and maxima. Okay. And so this implies f is many one. Okay. Also, since it is a cubic, okay, since f is cubic, range is all real. Range is all real. Hence, f is many one. F is many one on 2. Okay. Next. Okay. Try question number 5, everyone. Quickly. Yes, Oipsha, did you understand? And Debatri, you understood? Tell me.
Yes, sir.
Okay. Onani, did you understand number 4?
Yes, sir.
Okay, I'm solving number 5. Pay attention. It's given that the function x square plus bx plus 3 is not injective for values of x in the intervals 0, comma 1. Find the range of b. Okay, everyone pay attention. It's a quadratic, right? Concave upwards quadratic. Pay attention. Okay. It is said that it is not many one. Okay, number 5. It is said that it is not many one, not injective. I mean, not 1, 1, not injective in the interval 0, comma 1. So we need to think about 0, comma 1. Acha, what do you think? I'm drawing 3 cases, everyone. Case 1. You people have to tell me whether which one is 1, 1. Okay. This is the graph of the curve. This is the graph of the curve between 0, comma 1. This is case 1. Case 2. Tell me. In which case the function is 1, 1? Tell me. Tell me. In which case the function is 1, 1? Tell me, everyone. In which case the function is 1, 1? Tell me, it's very simple. By looking at the curve only, you should be able to understand in which cases or case the function is 1, 1. Tell me. Anyone raise your hand? Tell me. Between 0 to 1. See, you have to always think about 0 to 1. Okay, means only this portion of the curve. Only this portion. Yes, Raktim, tell me.
Sir, in the last graph.
In the last graph. Only in the last graph. What do you think?
No, sir, in case 2 also.
Case 2 also. Okay. That means try to understand wherever the vertex of the parabola, wherever the vertex of the parabola is outside 0 to 1, wherever the vertex of the parabola is outside 0 to 1, the function is injective. The function is not 1, 1, right? That means minus b by 2a must lie between 0 to 1. Right, tell me. Did you understand this logic? Yes or no? Minus b by 2a must lie between 0 to 1.
Yes.
Tell me, Shomita, Devang, Ritam, Onrini, Abhipsha, Debatri, did you people understand that minus b by 2a, the vertex of the parabola, should lie between 0 to 1? Tell me.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Okay, very simple. So let us start, everyone. Okay, what is minus b by 2a? That is minus b by 2, right? Everyone? Minus b by 2a means minus b by 2. Okay, minus b by 2 must belong to open 0, comma 1. Okay, this implies minus b belongs to 0, comma 2. Okay, this implies b belongs to minus 2, comma 0, open. Done. It's very simple. Okay, next. I'm solving number 6 also. Pay attention. F maps R to R. We need to determine the what kind of a function is this. Okay, f of x is equal to x square minus x plus 5 upon 7x square plus 2x plus 10. Okay, but everyone see. Okay, in number 6. Okay, we have got 2x square. F of x is equal to 2x square minus x plus 5 upon 7x square plus 2x plus 10. You people tell me, everyone, what is the discriminant of the numerator? Tell me. Discriminant of 2x square minus x plus 5. Tell me. You people are capable of finding the determinant. Tell me. What's the discriminant of 2x square minus x plus 5? Greater than 0 or less than 0?
Less than 0.
Less than 0, right? Okay. So can I say that 2x square minus x plus 5, the numerator is always greater than 0? Right. The numerator is always greater than 0. Acha, next. What is the discriminant of 7x square plus 2x plus 10? Tell me. What is the discriminant of 7x square plus 2x plus 10?
Sir, less than 0.
Less than 0. So can I say that 7x square plus 2x plus 10 is also always greater than 0? Okay. That means f of x is also always greater than 0. Hence, f is into. This much, I hope it is clear to everyone. Hence, f is always into. Okay, next. Okay. Now, what is f of 0? Tell me. Let us understand whether there exists, whether the function is into or onto. Tell me, what is f of 0, everyone? Calculate. Substitute the value of x equal to 0 and tell me what is f of 0. I hope you can substitute x equal to 0 and calculate the value of f of 0. F of 0 is equal to half. Okay. Now let us check whether there exists some other value of x also for which f of x equal to half or not. Okay. So putting 2x square minus x plus 5 upon 7x square plus 2x plus 10 is equal to half. Let us check whether there exists some other value of x or not. Okay, for which f of x equal to half. So cross multiply, we'll get 4x square minus 2x plus 10. This will be equal to 7x square plus 2x plus 10. Okay, let us simplify, everyone. We are going to get 3x square. Okay, see 10 will get cancelled. Okay, everyone. 3x square plus 4x equal to 0. Okay, so everyone, you see there are two such values of x equal to 0 and x equal to minus 4 by 3, for which f of x equal to half. Are you people getting? So tell me, f is 1, 1 or many 1? Tell me. What do you think? F is 1, 1 or many 1? Tell me.
Many one.
Many 1. Therefore, we can say f of x is many 1 into. Is it clear to everyone how to determine? you are having any doubt, you can ask me. Question number, I guess, 7. What kind of a function? What kind of a function is? What kind of a function is? Number 1, f maps R to R. F of x is equal to x cube plus x square. Only did you understand the previous problems? Plus 3x plus sin x.
Yes, sir.
Okay. Part 2, f maps minus infinity comma minus 1, open closed, to 0 comma e to the power 5. Okay. F of x is equal to e to the power x square minus 3x plus, wait a minute, e to the power x cube minus 3x plus 2. Question number 8. F maps R to R. Keep on solving, everyone. Tell me the answers. F maps R to R. F of x is defined as f of x is equal to x square plus 2mx minus 1 for x less than or equal to 0, and it will be equal to mx minus 1 for x greater than 0. Okay. If f of x is 1, 1, if f of x is 1, 1, find the range of n. Find the range of n. Solve. Okay. So everyone, okay, I think Vipsha has sent the answer. Let's see. Yes, so Vipsha, part one is correct. Devang, part one is correct. Devang, check part two. Raktim, part one is correct. Check part two. Oh, wait a minute. Raktim, both are correct. Yes, Shomita, part one is correct. Shomita, this is the answer. I mean, the second one is the answer of number 8.
Yes, sir.
Okay. Now check number 8. Ritam, part one is correct. Okay. Everyone, I'm solving part one. Pay attention. F of x is equal to x cube plus x square plus 3x plus sine x. Okay. You see, it's a cubic. Okay. It's a cubic. As x tends to infinity, what are we getting? Where we left tends to. In number 7, part 1, as x tends to infinity, okay, f tends to infinity. Okay. And as x tends to minus infinity, f also tends to minus infinity. Okay. So this implies f is on to. Okay. This much we can understand because it covers the whole of y-axis as the range is always r. Range of the function is always r. Tell me, are the people getting? Onini, are you solving? Tell me. Hello, Onini. Are you solving?
Yes, sir.
Okay.
Yes,
Next.
sir.
Now we need to understand whether it is injective or not. Okay. So first of all, let us see whether there exists a local maxima or local minima or not. F dash x will be equal to 3x square plus 2x plus 3 plus cos x. Okay. From here, you see we are getting 3x square plus 2x plus 1. I'm going to break it plus 2 plus cos x. Now you people can understand that this is always greater than 0. Greater than 0. And over here, the discriminant is less than 0. So we can say that f dash x is always greater than 0. Tell me, the battery, are you getting? This implies f is
Yes,
always
sir.
increasing, right? We have got f is always increasing. Therefore, f is bijective, 1, 1 on 2. Okay. Therefore, f is bijective. Next, solve part 2. Yes, Oipsha part 2 is correct. Everyone, let us start with part 2. F maps minus infinity comma minus 1 closed 0 to e to the power 5. We need to find out f of x is equal to x e to the power x cube minus 3x plus 2. Okay. So first of all, let us understand whether there exists a local maxima or local minima or not. Okay. So everyone, part 2. This is number 7, part 2. What you do is you differentiate. F dash x will be equal to e to the power x cube minus 3x plus 2 into 3x square minus 3. Okay. So you can understand that this part is always greater than 0. And there is a sign change of 3x square minus 3. Over here, what are the critical points? Minus 1 and 1. Okay. Before minus 1, it is positive, then negative, then positive. This implies f dash x is greater than 0. F dash x is greater than 0 for all x belongs to minus infinity comma minus 1. Okay. Union 1 comma infinity. And this implies f of x is increasing in f of x is increasing in minus infinity comma minus 1 because this is the domain set given. Domain is minus infinity comma minus 1. So once you understand that f of x is increasing in minus infinity comma minus 1, this implies f of x is 1, 1. Okay, so what have we got? I have got f of x is 1, 1, and f of x is always increasing in this interval. Okay, so let us find out the minimum and maximum value. So what is f of minus infinity? F of minus infinity is equal to e to the power minus infinity whole cube minus 3 into minus infinity plus 2, which is equal to e to the power minus infinity, which is 0. And f of minus 1 will be equal to e to the power minus 1 whole cube minus 3 into minus 1 plus 2. This will give us how much? 5 minus 1, which is 4, e to the power 4. Okay, so everyone, the range is, over here, the range of the function is 0 to e to the power 4. Okay, which is a proper subset of 0 to e to the power 5. Okay, hence f is 1, 1 into. Is it clear to everyone? Tell me, Devank, is it clear? Tell me, Devank, Shomita, is it clear?
Yes.
Yes, sir.
Okay, next. Question number 8. Let us start interpreting. Okay, there are two branches. One is x square plus 2mx minus 1 for less than or equal to 0, and it is equal to mx minus 1 for x greater than 0. Okay, we need to find out the values of x for which f of x is 1, 1. Okay, we need to find out the range of m. Okay, I'm going to draw the parabola for x less than or equal to 0. Okay, this is number 8. The parabola will look somewhat like this. Okay, f of 0 is equal to, you people can see f of 0 is equal to minus 1. Okay, so the parabola will look somewhat like this. Okay, for x less than or equal to 0. Next, you people tell me, everyone, this straight line depends upon this slope, m. Okay, everyone, m is the slope of the curve. Okay, tell me, is this line injective? I mean, if m is greater than 0, right? If m is greater than 0, means theta is positive. If theta is acute, then m is tan theta, which is greater than 0. So this is how it is going to look like. Tell me, if y equal to mx minus 1 is somewhat like this, then is the function injective? What do you think? In this case, is the function injective? Tell me.
Yes, sir.
Yeah, it is injective, right? Hmm? Raktim, what is an injective function? Hmm?
Sir,
What
for
is an
x
injective?
greater than 0, it will be injective.
No, no, no. I'm asking whether the whole function is injective or not. They are
No,
talking
no,
about the whole
in that
function,
case, it
na?
will not be injective.
It will not be injective,
Sir, I
right?
was
Will
telling for, yes, sir. I
no, no,
think you are
no,
asking about x is greater than 0.
no, no, no. Acha, next. For x equal to 0, if I put m equal to 0, okay, everyone, then it will be a straight line parallel to x-axis. Tell me. Now, in this case, is it injective? Now, the whole function is somewhat like this. Is it injective? Yes or no? Tell me. Will you get a straight line parallel to x-axis, which will cut the curve in at least two distinct points? Tell me. Is this function injective? Hello.
No,
Tell
sir.
me. No. Acha, I'll give you another example. Now, see, if m is less than 0, if the straight line is making an obtuse angle, is this function injective? Tell me. What do you think? Tell me, Raktim, Devang,
Yes, sir.
Onrini, are people getting?
Yes, sir.
Okay. So where does m belongs to? In this case, the function is injective. Therefore, m belongs to minus infinity comma 0. Done. If you people have any doubt, let me know. Tell me. Devatri, did you understand? Raktim, Onrini.
Yes, sir.
Okay.
Yes, sir.
Next. Our next topic is permutation-based problems. Okay, everyone. Permutation-based problems. Okay, permutation-based problems. Suppose F maps A to B. Suppose F maps A to B. Okay, case 1. When both set contains equal number of elements. Now see, permutation-based problems are very important. Every year, at least one question is there in JEE mains in one of the shifts. Okay, when both sets contain when both sets contain equal number of elements. Okay, when both sets contain equal number of elements. Okay, number one. Let us find out the total number of functions. Okay, total number of functions. Okay, how can we define the total number of functions, everyone? Okay, let us say set A contains four elements 1, 2, 3, 4, and set B contains, okay, A, B, C, D. Okay, so over here, how I'm going to define a function from A to B? Okay, let us say that these are books. There are four books and there are four shelves. Okay, now we need to define a function. So the number of functions can be compared. So the number of functions can be compared to distribution of four books, to distribution of four books in four shelves with no restrictions. Right, everyone? You are going to distribute these four elements into these four shelves. Okay, four books into these four shelves without any restriction. Okay, distribution of four books in four shelves with no restriction. With no restrictions. So tell me, everyone, what is the number of functions? In how many ways can you distribute four books in four shelves with no restriction? Raise your hand. Tell me. In how many ways can you distribute four books in four shelves with no restriction? Remember, no restriction. In how many ways can you distribute four books in four shelves with no restriction? Raise your hand. Tell me. Okay, yes, Aisha, tell me. What is the number of functions?
Sir, 4 to the power 4.
Very good. 4 into 4 into 4 into 4, which is equal to 4 to the power 4. What happened? Others also raise your hand. Devatri, Ondrini, Devang, Ritam, Shomita, raise your hands. Okay, 4 to the power 4. That will give us 256. Okay, next. Wait a minute. That is 4 to the power 4. Next. So, part 2, number of 1 functions. Tell me. Number of 1 functions. Number of 1 functions can be compared. Okay, pay attention. How can we relate it with books in a shelf? Number of 1 functions. Number of 1 functions can be compared to distributing. Can be compared. Can be compared to distributing. Can be compared to distributing four books in four shelves without repetition. Four books in four shelves without repetition. Tell me, in how many ways can you put four books in four shelves without repetition? Okay, that means each shelf will contain exactly one book without repetition. Tell me, everyone, each shelf will contain exactly one book. Yes, for this one, only tell me.
4 factorial.
4 factorial, absolutely correct. Are you people getting yes or no? Devank, are you getting?
Yes, sir.
Number of one functions. Number of one functions will be equal to 4 factorial. Next, part 3. So everyone, can anyone tell me what will be the number of many one functions in that case? Can anyone tell me? Yes, Olipsha, tell me what will be the number of many one
So
functions?
4 to the power 4 minus 4 factorial.
Very good, very good. 4 to the power 4 minus 4 factorial. Total number of functions minus the number of one functions. Next, let us talk about the number of onto functions. Okay, number 4. Number of onto functions. Okay. Over here, what is the meaning of number of onto functions? Pay attention. Okay. Means the whole of the codomain set should be exhausted. This can be compared. This can be compared to all the shelf getting all the shelf getting exactly one book. So tell me, how many onto functions will get exactly one book? How many onto functions will get? Raise your
4
hand.
factorial.
4 factorial. That is the number of one functions only. So the number of onto functions in this case, onto functions will be equal to 4 factorial. Okay, next. Number 5. So what is the number of into functions? What is the number of into functions? Tell me. If the total number of functions is 4 to the power 4, the number of onto functions is 4 factorial. So the number of into functions will be equal to, yes, Aisha, tell me.
So 4 to the power 4 minus 4 factorial.
Correct, absolutely correct. Tell me, Debatri, did you understand everything or should I explain?
No, sir, I understood.
And Ritam, did you understand? Next.
Yes, sir.
When the number of elements in A, when the number of elements in A is more than B, when the number of elements in A is more than B, pay attention, everyone. Okay, so that means let us say suppose A contains 5 elements. Okay, instead of 4 elements, let us say A contains 5 elements and B contains 4 elements. Okay, one by one, you people have to tell me the number of functions. Okay, number one, what is the number of functions over here? How many functions can you define from set A to set B? Raise your hand. Tell me. Tell me how many functions are there? Okay, now you have 5 books and 4 shelves. Yes, only tell me.
4 to the power of 5.
4 to the power of 5. Because each book will have 4 options. So number of functions will be 4 into 4 into 4 into 4 into 4, which is 4 to the power 5. 1024. Number 2. What is the number of one functions, everyone? Raise your hand. What is the number of one functions? Raise your hand. Number of one functions is like distributing 5 books in 4 shelves. 5 books in 4 shelves, such that such that each book is kept. Each book is kept in a unique shelf. Yes, so Ipsha, tell me how many?
0.
0. Absolutely correct. It's not possible only, right? Now there are 5 books and there are 4 shelves. Is it possible that you can keep all the books in 4 shelves such that each shelf is containing exactly one element? Okay, it's not possible. Okay, one shelf, one book will always be left out. Unique shelf. Okay, it's impossible. Okay, so over here, what is the number of one functions? Tell me. The number of one functions will be equal to 0. Next. So what is the number of many one functions? If the number of one function is equal to 0, what is the number of many one functions? Tell me. What is the number of many one functions? It will be 4 to the power 5 minus 0, which is 4 to the power 5. Yes, yes. Next. Number 4. Somebody tell me what is the number of onto functions? Over here, what you need to do? What is the number of onto functions? So I will give you the diagram, everyone. Okay. It can be possible like this. Okay. Five, there are five functions. I mean, there are five elements in A, but four elements in B. Okay. So two of the element will get mapped to one particular element. Yes. So somebody tell me how to proceed.
So is it 5p4 into 4?
No, you are mistaken. It's not 5p4 into 4. Okay. So in this case, everyone, in this case, what you need to do is you need to make groups. Already, why 5p4 into 4 will not work? Because try to understand. These two elements can be any two elements, right? These two elements can be any two elements, right? Mapped to a single element. Okay.
Yes, sir.
Okay. Next, everyone, number of onto functions. So it's like total ways to distribute. Total ways to distribute five books in four shelves. Five books in four shelves, such that each gets at least one book. Such that each gets at least one book. At least one book. So over here we need to make over here we need to make four groups of five. Okay. How to make groups? So can anyone tell me what is the total number of ways in which you can form total number of ways to form groups to form groups? Okay. Means you have to make groups of four, sorry, two, one, one, one. Tell me, in how many ways we can form groups of two and triple one?
5c2.
Why 5c2? You have forgotten. We have 5 factorial divided by 2 factorial into 1 factorial whole cube. Now there are three groups of equal strength. So multiplied by 1 by 3 factorial, right?
Yes, sir. Yes.
You remember it now?
Yes, sir.
Okay. Raktim, Devank, Shamita, are you getting?
Yes, sir.
Yes, sir.
Abhishek and Devatri, you know how to make groups.
Yes, sir.
You might have done this in PNC. Yes.
Yes, sir.
Rhythm, did you understand? Yes or no?
Yes, sir.
Okay. So after forming groups, what you need to do is, let us say that you have formed four groups, namely A, B, C, and D. Okay. Now there are four groups and you have to arrange it in four shelves. Okay. So the number of ways to distribute, number of ways to
So,
distribute.
but this is equal to 5C2. I was thinking
Yes,
that
yes,
I just need
yes.
to make one group
Yes, you're
of two
correct
and the
only.
rest. Yeah.
Coincidentally, it is coming out to be 5 factorial divided by 2 factorial into 3 factorial only. You see?
So I was thinking we just need to make one group where there's two and the rest form like one each anyways.
Achha. Okay. So the number of ways to distribute four groups in four shelves will be equal to 4 factorial. So the total number of onto functions will be, total number of onto functions will be equal to 5 factorial divided by 1 factorial whole cube into 2 factorial into 1 by 3 factorial whole into 4 factorial. We need to arrange it as well. Tell me, is it clear to everyone? Devatri, did you understand why I multiplied by 4 factorial?
Yes,
Because
sir.
after that, we need to arrange four groups in four shelves also. Tell me, Raktim, Devang, Shomita, is it clear?
Yes, sir.
Yes, sir.
Okay. Shomita, did you understand?
Yes, sir.
Okay. Next, so this is the total number of onto functions. What is the number of into functions? The number of into functions will be equal to, yes, Shomita, tell me. Shomita, I cannot hear you. It will be equal to 4 to the power 5 minus this expression. Okay. Next, case 3. When the number of elements in the codomain, when the number of elements in the codomain set, in the codomain set is more than the domain set. Okay. So over here, let us say that the set B, codomain set contains one extra element. Set A contains 1, 2, 3, 4. Okay. Set B contains, okay. So set B contains A, B, C, D, E. Okay, this is what set B is. Acha, what is the total number of functions? Raise your hand. Tell me. Total number of functions. Anyone tell me? Yes, Oipsha, tell me.
The 5 to the power 4.
5 to the power 4. Absolutely correct. If you people are having any doubt, let me know. Number 2. Number of 1 functions. Raise your hand. Tell me. Raise your hand. Number of 1 functions. Tell me. Anyone tell me? What is the number of 1 functions? Now see, you have 4 books and 5 shelves. Right, everyone? You have 4 books in 5 shelves. So first of all, you will select. Yes, Raktim, tell me.
Sir, 5c4 into 4 factorial.
5c4 into 4 factorial. Correct. Okay. Next, what is the number of one functions? Oh, one function, we have done it. So what is the number of many one function? Number of many one functions? Yes, Abhishek, tell me.
So 5 to the power 4 minus 5c4 into 4 factorial.
Correct, correct. Next, number 4. What is the number of onto functions? Okay. The number of onto functions, anyone tell me? Raise your hand. How many onto functions we can define from set A to set B? Tell me. Yes, Onini, tell me.
0.
0. Over here, we cannot. Okay. Over here, we cannot define such a function such that all the elements of codomain set is exhausted. Okay. You cannot diverge. Okay, everyone, you cannot diverge. You can converge but cannot diverge. Okay. Okay. So what is the number of into functions? It's very simple. Number of into functions will be, yes, Onini, tell me.
5 to the power 4.
5 to the power 4. Okay. So let us do some problems. Devatri, you understood? Devatri, Shaumita,
Yes.
Abhiksha, is it clear? Raktim, Devang.
Yes, sir.
Okay.
Yes.
What was the last question we did? And every year, one question you will get from permutation-based problems. Okay. Question number, what was the last question we did? 7 part 2, 8. Question number 9. Question number 9. F maps A to B. F maps A to A, where A is equal to, okay, F maps A to A, where A is equal to 1, 2, 3, 4. Find the number of bijective functions such that, find the number of, okay, find the number of, find the number of bijective functions F, okay, find the number of bijective functions F such that, find the number of bijective functions F of x such that F of 1 is not equal to 3, F of 2 is not equal to 1, F of 3 is not equal to 4, and F of, okay, Okay, f of 3 is not equal to 4. F of 3, f of 4 is not equal to 2. Wait, is not equal to 2. Quickly solve. Okay, and this is question number 10. Okay, is number 9 done, everyone? Okay, this is question number 10. Okay, everyone, I'm solving number 9. Pay attention. Okay, this is question number 11. What is written, everyone? F maps A to A equal to 1, 2, 3, 4. We need to find out the number of bijective functions f of x such that f of 1 is not equal to 3, f of 2 is not equal to 1, f of 3 is not equal to 4, and f of 4 is not equal to 2. Right, everyone? So consider, everyone pay attention. Consider, consider that there is a set A, okay, 1, 2, 3, 4, and there is another set B, okay, 1, 2, 3, 4, okay. So suppose f of 1 was equal to, suppose f of 1 was supposed to be equal to 3 only. F of 2 was supposed to be equal to 1 only. F of 3 was supposed to be equal to 4. And f of 4 was supposed to be equal to 2. Okay, everyone. These were their designated images. Okay, everyone. These were their designated images. Right. So can we compare this problem? Can I compare this problem? Okay, to the number of ways to arrange 4 letters in 4 envelopes. 4 envelopes such that, do you remember everyone? It's like dearrangement only, number of ways to dearrange. Derange. Okay. Such that f of 1 is not equal to 3. Such that f of 1 is not equal to 3. F of 2 is not equal to 1. F of 3 is not equal to 4. And f of 4 is not equal to 2.
Sir, can you please explain why is it derangement?
Because let us say that letter number 1 was supposed to go to letter number 3 only. Let us say letter number 2 was supposed to go to letter 1, I mean envelope 1. And letter number 3 was supposed to go to envelope number 4. And letter number 4 was supposed to go to envelope number 2. Okay. Understood. These were the designated envelopes. Okay. Now we need to dearrange in such a way such that they don't go to their designated envelopes. So it's like dearrangement, right? Tell me.
Yes, sir.
Are you getting Shamita, Raktim? Tell me.
Yes, sir.
Yes, sir.
And Already, Avisha, Debatri, you people know what is dearrangement. Avisha and Debatri, you know what is dearrangement?
Yes, sir.
Debatri, you know? If you
Sir,
don't
I
know, tell
don't.
me, I'll explain. Okay, okay. Dearrangement means, let us say that you have n letters and n envelopes. Okay. You have n letters L1, L2 up to Ln and n envelopes E1, E2 up to En. Okay. Devatri, are you getting? Okay.
Yes, sir.
Now letter 1 is supposed to go to envelope 1. Okay. Letter 2 is supposed to go to envelope 2. Letter 3 is supposed to go to envelope 3. Okay. Letter N is supposed to go to envelope 1. So the to number of ways to put letters into envelopes such that letter 1 is not going to envelope 1. The letter 2 is not going to envelope 2. Means none of the letters is going to their designated envelope is known as DN. Means dearrangement
Okay,
of n
sir.
things.
Got it, sir.
Understood?
Yes, sir.
Like you see, I'll give you an example for L L3, I mean D3, okay. This is L1, L2, L3, D1, D2, D3. So in how many ways can you arrange such that letter 1 does not goes to envelope 1, letter 2 does not go to envelope 2, letter 3 does not goes to envelope 3. So tell me, L1 has how many options? Tell me.
So two.
Avisha, Debatri, two options. Either it will go to E2 or E3. Suppose L1 goes to E2. Then L2 has how many options? Two options. L2 can go to
Yes, sir.
E3. But can L2 go to E1? Can L2 go to E1? What do you think? See,
No,
if
sir.
L2 goes to if L2 goes to E1, then L3 will have to go to E3, which is a clear violation.
Yes, sir.
Are you getting? L2 has to go to E3 and L3 has to go to E1. So this is one way to dearrange. Another way to dearrange is, tell me, Raktim, Devang, are you people able to recall dearrangement?
Yes, sir.
Okay.
Yes, sir.
L1 has an option to go to E3. L2 then have to go to E1. L3 then have to go to E2. So can I say that D3 is equal to 2? Tell me. Are you getting?
Yes, sir.
Shamita, Abhisha.
Yes, sir.
Yes, sir.
Okay. And there was a direct formula. Dn is equal to n factorial within brackets 1 by 0 factorial minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial dot 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 dot. It goes on like this. Is it clear, Devatri? So over here,
Yes, sir.
what is your answer? Over here, the number of functions will be equal to number of functions will be equal to D4, right? Because we have to dearrange four letters, four objects into their four images. D4 is equal to 4 factorial into 1 by 0 factorial minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. Okay. Devatri, are you getting? See, I'm using the formula D4. These two gets cancelled. When you open the brackets, you are going to get 24 by 2, which is 12, minus 24 by 6, that is 4, plus 1, that will give us 9. So your final answer is 9.
Yes, sir, I
Is
got
it
it.
clear, Devatri, Aisha? Okay. Devank, is it clear? Are you able to recall the arrangement now?
Yes, sir.
Okay. And Raktim, is it clear?
Yes, sir.
Okay. You people solve 11 quickly. Okay, I'm going to solve 11. Pay attention. There are 20 elements in set A. Let us call this set A. And there are 20 elements in set B. Okay. We need to find out the number of functions, number of onto functions, such that f of k is a multiple of 3 whenever k is a multiple of 4. Pay attention, everyone. Okay. Whenever k is a multiple of 4. So everyone pay attention. What are the values of k that tell me? From 1 to 20, what are the multiples of 4? Tell me. Start telling me the multiples of 4. It will be 4, 8, 12, 16, and 20, right? Tell me, everyone. And what are the multiples of 3 which f of k can take? Multiples of 3 will be 3, 6, 9, 12, 15, 18. Tell me. Are people getting? So what is the total number of onto functions? Total number of onto functions will be equal to what? First of all, it will select any of the 5. Okay. Total number of functions onto functions will be equal to 65 into. Then after that, we have to arrange it also, multiplied by 5 factorial. Then arrangement of the remaining elements, that is 15 factorial. Tell me, is it clear? Raktim, Devang, Memel. Oh, Memel is not. Onini, Shomita, Ritam, is it clear? Debatri, is it
Yes, sir.
clear?
Yes, sir.
Okay. Abhipsha, you understood? Tell me.
Yes, sir.
Next. Our next
Yes.
topic is functional equation. Raktim, is it clear? Tell me.
Yes, sir.
Functional equations. And Devang, did you understand the previous problem?
Yes, sir.
Okay. Functional equations. Okay. Every year, one question will definitely come from functional equations. Okay. You see, this year also it came. Okay. For example, for x belongs to real numbers. Okay. This one I'll solve. Next one you people will try. For x belongs to real. Okay. The function f of x satisfies. The function f of x satisfies. The function f of x satisfies 2f of x plus f of 1 minus x is equal to x. Find f of 4. So see everyone, how you can do it. Pay attention. So see, there are two variables in front of you. Okay. So you utilize it. What you do is you put x equal to 4 first. Putting x equal to 4 so that we get f of 4. Putting x equal to 4, we get 2f of 4 plus f of minus 3 is equal to 4. Are you people getting? This is equation 1. Next. Acha, tell me, just like I got x equal to 4 over here, I want 4 over here also. So tell me, what should we substitute as x so that we get 4 over here in this functional term? Tell me. In this term, I need 4. X equal to
Minus 3.
minus 3. Absolutely correct. Put x equal to minus 3. What do we get? We get 2f of minus 3 plus f of 4 is equal to minus 3. So I've got two equations in two variables. Now we need to solve. Okay, everyone. One of the equation I've got 2f of 4 plus f of minus 3, which is equal to 4. Okay. So what you do is you multiply. I need the value of f of 4, right? So multiply the second equation by 2 and subtract. Okay, everyone. What are we getting? I'm going to get minus 3 into f of 4 will be equal to minus 3 minus 8 minus 11. Let me see. Minus 3 into f of 4, no? Okay. Tell me, are the people getting yes or no? So from here, what's the value of f of 4? F of 4 is equal to 11 by 3. Okay. See, this is one of the methods. Method 2. Okay. You can directly find out the value of f of x. Okay. So suppose 2f of x, and this is what is given to us, 2f of x plus f of 1 minus x is equal to x. Okay. So what you do is you replace x by 1 minus x. What do we get? You get 2f of 1 minus x plus f of 1 minus x will become f of x is equal to 1 minus x. Now you see everyone, again I've got two equations in two variables. So multiply the first equation by 2 and then I'm going to subtract. Okay, when you subtract f of 1 minus x, f of 1 minus x gets cancelled. You are going to get 3f of x is equal to 2x plus x minus 1, that is 3x minus 1. So everyone, f of x is equal to 3x minus 1 by 3. Tell me, is it clear to everyone? Tell me. Abhipsha, Andrini, Raktim, Devank, Ritam, are people getting?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Abhipsha
Yes, sir.
and Devatri, you understood? Tell me.
Yes, sir.
Okay. So let us do some problems. Okay, everyone, on functional equations. Try this out. Okay, solve everyone. Okay, use the same logic, everyone. You get the result. Use the same logic. Find out the composite. Okay, nobody has written the answer. Okay, so everyone pay attention. Same thing. Again, you have to do the same thing. Okay. Replace x by 1 by x. One of the equation you have got it as the number 7. Okay. So over here you replace x by 1 by x. What do we get? You'll get 2f of 1 by x square plus 3f of x square is equal to 1 by x. Okay. And what is the next equation we have got? 3f of 1 by x square plus 2f of x square
Is the answer option B?
is equal to, yes, your answer is correct, is equal to x. Now my task is to find out f of x square. In order to find out f of x square, multiply the first equation by 3 and second equation by 2 and subtract. You see, these two will get cancelled. We are going to get 9 minus 4, that is 5 f of x square will give us 5 by x. So this implies f of x square will be equal to, so from here 5 into f of x square is equal to,
2x plus 3 by
I
x.
don't know why. This will be x plus 1 by x, sorry. This will be x plus 1 by x. Oh, wait a minute, not x plus 3 by x minus 2x. Okay, sorry. So everyone, this will give us how much? F of x square will be equal to 3 minus 2x square upon 5x. Okay. So hence the answer is option number B. Okay, everyone solve number 8. Okay, I'm solving number 8. Pay attention. Anyone who has done number 8? No. Pay attention. Number 8. Okay. Number 8, it is given f of x and g of x with polynomials which take integers as arguments. Suppose f of x plus y is equal to f of x plus g of y plus 8. And f of x is equal to x for all negative integers. Okay. And g of 8 is equal to 17. We need to find out f of 0. Okay, what is f of 0? Okay, f of 0, putting x equal to minus 8, then only we are going to get f of 0, putting x equal to minus 8 and y is equal to 8. Okay, so then only we are going to get f of 0. Okay, So over here, okay, f of 0. Okay, let us start. So what is f of minus 8 plus 8? F of minus 8 plus 8 will also give us f of 0. My task is to find out f of 0 only. F of minus 8 plus 8 will be equal to f of minus 8 plus g of 8 plus 8. Okay, so what is f of 0? F of 0 will be equal to, you see, f of minus 8 will be equal to minus 8 only because f of x equal to x for all negative integers. What is g of 8? G of 8 is given. G of 8 is given
Yes, sir. 17.
17. So plus 17 plus 8. This will give us how much? 17. Yes, 17 is the correct answer. Tell me, are you people getting? Devatri, you understood this one properly? Two-line problem.
Yes, sir.
And Avishya, did you understand?
Yes, sir.
Raktim,
Yes, sir.
Onrini is, did you understand? Onrini, Ritam, did you understand?
Yes, sir.
Okay. Next one. Okay. Next ones. Pay attention. Okay, I'm posting another questions. I mean, another set of questions. Okay, these are number 9 and 10. Okay, solve everyone. Question number 9 and 10. These are 9 and 10. Okay, think how will you get f of minus 7 equal to, I mean, how can you utilize f of minus 7 equal to 7? Okay, so everyone pay attention. My task over here is to find out f of 7. Okay, my task over here is to find out f of 7. Hello, what is f of 7? Tell me. Everyone, tell me. Shwamita, are you there?
Yes, sir. Solving.
Okay. What is f of 7? F of 7 will be equal to a into 7 to the power 7 plus b into 7 cube plus c into 7 minus 5. And g of 7 will be equal to, g of 7 will be equal to, okay, let's forget about g of 7. Oh, g of 7 is not even there. Okay, let us write down f of minus 7. F of minus 7 is given as 7, which will be equal to a into minus 7 whole cube plus b into minus 7. This is whole to the power 7. B into minus 7 whole cube plus c into plus minus 7 into 7. Okay. Find f of 7. You need to find out f of 7. Okay. So what you can do is over here is c. If you add, some of the terms will get cancelled. Like see, this will get cancelled. Okay. And some more people. Okay. So over here, when you add, what are you getting? F of minus 7 is given as 7. So this implies f of 7 plus 7. This will be equal to, how much is left? Minus 7 into 7.
Sir, minus 10. Sir,
Minus
no
10.
minus to C.
Then minus 5 should also be there, right?
Yes, sir. Then, sir, only minus 10 is there.
Only minus 10 it will win. Acha, over here, C also should be.
Yes, sir. There should be C in place of 7.
Instead of 7, it should be C. Okay. So see, all these terms will get cancelled. You are going to get minus 10. So everyone, what is f of 7? F of 7 is equal to minus 17. Tell me. Is it clear to everyone? Tell me. Anyone having any doubt, you can ask me now. Okay, should I solve 10, everyone? Devank, did you understand number 9? Devank, Raktim, Shamita,
Yes, sir.
or Nini, did you understand number 9? Abhipsha, Devatri, did people understand?
Yes, sir.
Yes, sir.
And Ritam, did you understand? Yes or no?
Yes, sir.
Okay. Next, again, over here also we have to do the same thing. Okay. We have to utilize f of minus 2 and f of 1. So substitute f minus 2 first. Okay. Putting x equal to minus 2. What do we get? Putting x equal to minus 2. What do we get? We'll get m into f of minus f of minus 2 is equal to okay, number 10. I need to utilize f of minus 2. No? If you put x equal to minus 2, we are not getting f of 2. Okay. So instead of that, what you do is you put x equal to minus 1. Then we are getting f of minus 2 in the first one. We will get m into f of minus 2 plus n into f of 1 is equal to 2 into mod of x plus 1. So see everyone, what is f of minus 2? F of minus 2 is equal to f of minus 2 is given as 5. So this implies 5m plus f of 1 is given as plus n is equal to 2 into mod of x plus 1. Okay, so 2 into minus 1 plus 1. That is 2 plus 1. So 5m plus n. From here I have got one equation. 5m plus n is equal to 3. Tell me, are you people getting? This is one equation. Next, another equation we'll get by putting x is equal to 3. 3 minus 1 is equal to 2. No, no, no. I need f of minus 2. I need f of 1 as well. So put x equal to 2. Okay, everyone. Putting x equal to 2, what do we get? We'll get m into f of 1 plus n into f of minus 2. This will be equal to 5. Next. So over here, my task is to find out, okay, what is f of 1? F of 1 is equal to 1 and f of minus 2 is equal to 5. So f of 1 plus 5 into f of minus 2. What is f of minus 2? F of minus 2 is given as 5. So that is 5 only. So plus 5n. And f of 1 is given as 1. So over here I'm getting m plus 5n is equal to 5. Tell me, are the people getting Abhipsha, Devatri, Raktim,
Yes, sir.
Yes, sir.
Devang, Onrini, Shomita? Did you
Yes.
people understand? Okay. My task is to find out m plus n. Okay. So m plus 5n equal to 5 and 5m plus n is equal to 3. Tell me, how can we find out m plus n? Over here.
So multiplying 5 with the second equation and subtracting it from the first equation.
Okay. Any other way which can be done quickly? Okay. So when you add, you're
So
going
put
to get,
m equal to 5 minus 5n.
see, when you add, you'll get 6 into m plus n, which is equal to 8. So m plus n is equal to 8 by 6, which is 4 by 3. Tell me, is it clear to everyone? Yes, 4 by 3. Anyone having any doubt till now? It's very simple, right? Okay. If there's anyone having any doubt, you can ask me now. Next. Okay, our next topic is composite of uniformly and non-uniformly defined functions. Composite of uniformly and non-uniformly defined functions. Okay, so what is the meaning of composite functions? Pay attention. What is the meaning of composite functions? Pay attention. So let F maps A to B. Let F maps A to B and G maps B to C. Okay, B2 functions. B2 functions. Then the then the function then the function GOF maps A to C is defined by is defined by G of F equal X will be equal to G of F of X. Okay, for all X belongs to A. For all X belongs to A. It's called the composite of two functions. It's called the composite of two functions. Are the people getting? Tell me. It's called the composite of two functions. Okay. And how do we represent diagrammatically? F and G can diagrammatically be shown as diagrammatically diagrammatically like this. First of all, you are going to substitute x in f. Okay, it will become f of x. And then you are going to substitute f of x in g of x to get g of f of x. Are people getting? First of all, you are going to substitute x in f, find f of x. Then you are going to substitute f of x in g of x to get g of f of x. Okay, I hope it is clear to everyone. Okay. Like for example, I'll give you an example. Okay. For example, suppose g of x is equal to root over 2 minus x. Okay. Number one. Acha, what is g of x? G of x will be equal to g of x, which is equal to g of root over 2 minus x. Tell me, are the people getting those who are online? It will become g of root over 2 minus x, which is equal to root over 2 minus root over 2 minus x. Tell me, are the people getting? Tell me, Raktim, Devank, Onlini, Shomita, did you people understand?
Yes, sir.
Okay. Understand the Batri? Ritam, is
Yes.
it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Ritam? Okay.
Yes.
Acha, over here, if I ask you what's the domain, can anyone tell me the domain of this function? Tell me the domain and the range. Anyone? What's the domain and range of this function? Tell me, everyone. Domain and range. Acha, solve it in your copy and then tell.
Sir, minus 2 to 2 domain.
Domain is minus 2 to 2. Yes, it is correct. Right. How to find out the domain? Pay attention. First of all, 2 minus x must be greater than 0, greater than or equal to 0, and root over and 2 minus root over 2 minus x must be greater than or equal to 0. So from here we are getting x is less than or equal to 2, and from here we are going to get root over 2 minus x is less than or equal to 2. Okay, squaring both sides we are getting 2 minus x is less than or equal to 4. So from here x must be greater than or equal to minus 2. This implies x belongs to minus 2 to 2. Tell me, is it clear to everyone? Shamita, is it clear? Abhisha, Devatri,
Yes.
Ritam, are you
Yes,
getting?
sir.
Tell me. Acha,
Sir, range 0 comma root 2.
yes. Range of GOG. Range of GOG will be equal to, you just directly substitute minus 2 comma 2 in the function. It will be equal to root over 2 minus root over 2 minus minus 2 to 2. Okay, this will give us how much? Root over 2 minus root over 2 minus, acha, 2 minus of minus 2 will give us 4. 2 minus 2 is 0. So this will give us 0 comma 4. Now square root of 0 comma 4 will give us root over 2 minus 0 comma 2. Okay, next. This will give us root over 2 minus 0 is 2 and 2 minus 2 is 0. So close 0 comma 2, which is close 0 comma root 2. I hope this is clear to everyone. Tell me. Only is it clear? Hello, Nini. Did you understand the meaning of composite functions? Hello. Nini, are you there? Okay. Abhisha, did you understand? Abhisha, Devatri, Devank,
Yes,
Raktim,
sir.
did you people
Yes, sir.
understand?
Yes, sir.
Yes, sir.
Ritam and Shamita, did you people understand?
Yes, sir.
Yes, sir.
Okay. Okay, so we have done a lot of topics today, everyone. Next, okay. I think everyone, we can keep it till now. Okay. Next class, we'll again continue. Next class, we'll continue with composite functions. Okay. Of uniformly and non-uniformly defined functions. I'll give some more examples. Okay. So till then, thank you everyone and good night. I'll send everything. Okay, thank you and good night everyone. Okay.
Good night, sir.
Okay.
Yes.